How good was that lunch? I'm glad that I was not the person standing between you and lunch. I feel sorry for the last speaker, but glad to be the one talking to you all after lunch. Okay, so my name is Pradeep. I'm a senior technologist in the applications platform architecture team. And in the next 30 minutes, we'll be talking about a brand new topic which you haven't heard about in the past 1.5 days. Again, it's about AI and ML. But in 30 minutes, we'll be focusing on principles and processes, and we'll be focusing on less on technology, but more in terms of processes as to how you would enable your teams to build innovative AI and ML models. That's a whole conversation about. But before we jump into it, I'll give you all a few seconds to read through the disclaimer. Okay, cool. So in terms of an agenda, next 30 minutes, you're going to be talking about digital transformation, and we'll be primarily focusing on data transformation, which is a key aspect of your digital transformation. We'll also be looking at Datamesh as one of the key ways of ensuring digital transformation with a primary focus on data transformation within your organization. We'll be looking at the concept of data products, which are a cornerstone within the Datamesh architecture. Then we're looking at the concept of a data mesh platform and how a data mesh platform enables you to innovate and build better AI and ML models. And then we'll be looking at how a data mesh platform enables data science, which in turn unlocks innovation within your teams to build better AI and ML models. We've had a lot of discussions about private AI and a bunch of other technologies, but in this conversation, we'll be focusing primarily around how to enable your teams to use all those technologies in a much more effective way, right? And as we're talking about this conversation, a lot of organizations are going through a huge amount of digital transformation. Yesterday, Raghu talked about digital transformation across the decades from web-based applications, cloud-native architectures, mobile applications, and currently we're going through a decade of transformation maybe in terms of AI and ML technologies. While we are going through that digital transformation, data is becoming key to all of this transformation in this decade. Now, what does this digital transformation mean from a data perspective? When I look at data transformation through this lens, I look at it in this particular way, wherein most of the organizations look at data transformation initially from a data defense perspective, where they're heavily focused on factors such as data encryption, data loss prevention. There is a lot of emphasis and focus on ensuring that they can secure their data and that their data has good quality and that they can use the data with the necessary controls on it. Now, that's one direction which a lot of organizations focus on, but they would ideally like to move from data defense, when they have achieved strong data foundations, they would really like to move towards the left side of this graph, which is primarily to achieve value from your applied intelligence. But it's not an easy one, because as you want to move more to the left, there is a lot more you need to do in terms of ensuring that you can get value from your data in terms of using applied analytics, in terms of using prescriptive analytics, in terms of using AI and ML models. And that's what this conversation is about. How do you ensure that your organization can sort of shift left as quickly as possible so that you can sort of use all these technologies that we are announcing and you can empower people within your organization, right? But why are we having this conversation currently? If you look at data architecture across a lot of organizations, I'm sort of trying to generalize, but data architecture across a lot of organizations follows a very, very similar pattern. You generally tend to have operational data plane, what we call as an operational data plane. This is where data is acquired from a lot of source systems. It could be most of your front-end systems. And in your operational data plane, teams are focused on primarily transactional data. They're focused on asset properties, atomicity, consistency, durability, and integrity. They're focused on small-scale data. And these are primarily domain teams. Just a show of hands, how many of you know about domain-driven design, domain teams? Okay, cool. So these domain teams are primarily focused on achieving a particular business outcome, and they focus primarily on data within these particular domains. And these domain teams use polyglot data tools. Each team has its own set of data stack which they use to manage this particular data, right? Now, from here, data is generally extracted through data pipelines. These data pipelines transform this data, they enrich this data, they cleanse this data, and they sort of are primarily working towards loading all of this data into what we call as an analytical data plane. And this is where you deal with data in the large scale, right? Here we're talking about aggregation of data, summarization of data, rolling up data to achieve intelligence from all of this data, right? And one other major factor over here is that here we're dealing with functional teams. The primary difference in terms of how teams are organized: in the operational data plane, teams are organized in terms of domains which are much more business oriented, whereas in the analytical data plane, you're talking about teams which are organized functionally. You might have a group of SQL developers. You might have a team of DBAs. You might have a team of BI developers. And that's where there are primary differences over here, right? A lot of other differences too. For example, data tools, where you have polyglot data tools on your operational data plane. In your analytical data plane, you generally tend to have a single stack across the whole organization, right? So this is a general trend of how data architecture is managed across multiple organizations. Now, what are the primary challenges? I'm not saying this architecture is bad. This architecture works. A lot of organizations follow this architecture, and it works for them. But still, what can we do better, and why do we think there's a better way of doing it? One of the primary challenges is this data architecture is highly monolithic in nature. Most of this data is in a large data warehouse. It could be a data lake or a delta lake or whatever you call it. But it's still managed in this huge monolithic system, right? And having this monolithic system is pretty hard because now you're talking about moving everything into the single system. And since you have this monolithic system, there's a lot of latency. It's not surprising that a lot of organizations, if you want any sort of analytical report or a management report, which requires a lot of advanced intelligence within it, there is a lag time of at least 8 to 20 hours easy. I know an organization where they want to know about how many opportunities or leads are generated on a daily basis, and it takes almost 14 to 15 hours to generate that report, right? Because all of this data is pipelined, there is no domain boundaries between this data, and this data has to be really acquired from multiple sources. And this results in having limited real-time insights. We're moving to a world where people really want to have real-time insights. They don't want to wait 8 to 9 hours to get some sort of insight from all the data that they have acquired. They want insights and data now, and really now. Scaling this sort of a system is highly expensive, purely because, again, it's a monolith. There is a tech stack which is highly vendor dependent, and most of this data is resident in the system, so you'll have to migrate this data across. So it's not easy to scale the system. And to manage the system is also expensive because now you've moved all your critical data assets into this single system, where you've also increased your risk, which means any operational cost on this thing is going to be really high. So how do you transform this data architecture? Now, as I said, this data architecture works, but there are better ways of doing it, purely based on these particular challenges. Now, there are many ways of transforming this architecture to do better. I'm not saying one way is better or one way is not so good. It depends on your pros and cons and what are you willing to trade off. That's what architecture is all about, as to what are you willing to trade off for this architecture, right? So based on that, data mesh is one way. A data mesh is an architecture principle, wherein it's one way of ensuring that you can have a better data architecture, which allows you to take care of those challenges. The primary areas where a data mesh focuses on are into transforming your monolithic data architecture into a platform. And primarily this is because it wants to enable self-serve data products. The primary areas being democratization and decentralization of data. And this would result in scalability. Once you democratize and decentralize your data, your teams can scale this data independently, and this also results in agility. That's what data mesh primarily tries to achieve. We'll look at the primary principles of data mesh. There are 4 primary principles. The first one is domain-oriented ownership. As I said, where there is monolithic data ownership, we are moving it down and breaking it down and decentralizing it, and we are democratizing data, and we are saying domain teams own the data that they generate. So data stays at the source rather than having to move it into a monolithic system down the line, right? So these teams own the data that they generate. They manage it. They're responsible for its data quality and usability and delivery. And since now that we have democratized and decentralized data, it can be scaled horizontally. The second concept is the concept of a data as a product. Now, this comes in because now that you have distributed data into your domain teams and decentralized it, there is a risk of siloing of data, wherein data sort of silos into these teams. And that's the reason why we introduce the concept of data as a product, wherein we say data is a first-class citizen, and it's got specific standards and interfaces around which we build these data products. And these data products are, again, developed and managed by these domain-oriented teams. And these teams can then sort of continuously improve their data product and own those data products in the overall life cycle of that particular data product. And now, since the team owns that data product, and we want to ensure that there is other teams can use that data product, that's where the concept of federated computational governance comes in. What we are saying is this governance structure ensures that the data products built by these teams adhere to certain standards, and they can be interoperable across multiple teams. The key aspect over here is we are talking about computational governance. We're not talking about a governance document in a Word document or a SharePoint or some sort of a Confluence page. We're talking about policy as code, and we're talking about those sort of aspects where you can automatically have in governance policies embedded into your systems, right? The last one is, now that we have empowered our teams to own their data, we have allowed them to start building data products, and we're putting governance structures in place. We need to ensure that the teams are successful in provisioning the necessary infrastructure that they need to build their data products. We have infrastructure as code, so these teams, we're again making them independent to provision any sort of infrastructure that the platform allows them to provision, right? It could be an Amazon RDS instance, it could be a Kubeflow instance, it could be an Azure Cosmos DB instance, and that's where we try to be as independent of the implementation in terms of enabling this platform. So these are the primary data mesh principles. Within these principles, there are two areas that I would primarily like to focus on. One is data product. Data products are key to a data mesh architecture. This is what enables a data architecture to shine in terms of enabling teams to be democratic and decentralized and ensure that they can own the data products that they generate. So the primary concept of a data product is that it's an architectural quantum where it can be developed and deployed independently and managed independently by the team. It's an autonomous system wherein it has everything contained within itself to operate, and it's not dependent on external factors. It's completely self-contained, and a data product has well-defined interfaces. We will look at a deep dive of a data product. It has well-defined interfaces in terms of how does it ingest data and what's the sort of output that it produces and how it can be managed by the platform. It can be independently scaled because it's autonomous in nature. It is highly cohesive in nature, and there is low coupling because of the standard interfaces that you've defined across. A data product is highly discoverable because that's what the platform allows you to do. It allows you to discover, document, and understand much more about a data product. And a data product, one of the key areas is that it's highly interoperable because of the interfaces that we define around it. And since it's highly interoperable, it's also reusable. So we'll start to look more about a data product. For example, I'm showing you a data product which is owned by the cart domain. And this is where things change. Rather than saying this cart data has to be queried only from your data warehouse or a data lake. We're talking about this data existing within the domain, and you ask for the data within the domain where it makes a lot more sense because there's a lot more context around it with the source data that it's being generated from. All right? We'll try and look at a deeper aspect of what does a data product consist of. When I drew this diagram, one of my colleagues remarked it looked like an alien crab, but this is the best I could manage. A data product primarily consists of an input layer. We generally also call it as input ports. And this could be data that it's sourcing from. This is data that it's ingesting. It could be ingesting data from a REST API. It could be ingesting data from an event store, a bunch of events coming in from an event store, streaming data. It could be ingesting data from a SQL store through a JDBC or an ODBC connection, or even from a file store from which it's ingesting CSV files or Parquet files as an example. The second part of a data product is the processing layer. This is where the data product makes sense of the data that it has ingested and sort of adds intelligence to the whole process. It could be summarizing that data, aggregating that data, or it could be doing feature extraction, model training, or whatever you want in terms of adding value to the data that you ingested. The third part is the output layer, where it then outputs the applied data intelligence that it generated based on data that it ingested. And this could be anything, again. It could be a REST API, it could be a GraphQL API, it could be a Parquet file. It's about the interface that this data product defines. But more critically, a data product also has a control layer, and this control layer is used to manage the lifecycle of the data product. And this is what allows it to be discoverable, this is what allows it to be well documented, and this is what allows it to be plugged into a platform, right? So this, for me, is a key aspect of a data product, and this is what shines through in a data mesh platform. And what have we achieved with the data mesh platform and a data product right now? What we have done right now is that we have enabled and empowered your domain teams to create these data products. We have enabled discoverability. We enabled these domain teams to independently manage the lifecycle of these data products. And we have sort of democratized and decentralized data into these domain teams rather than that staying in a single monolithic data warehouse or a data lake house. And these data products are highly interoperable. For example, over here, if you're in an e-commerce domain, you could have the cart team create an abandoned cart data product, which could be streaming data in terms of whenever carts are abandoned for somebody else in the other domains to use that data. Or you could have the marketing team create a campaigns data product, which allows people to access campaign data as an example. You don't need to always go back into a data warehouse or somewhere else to achieve this and sort of unlock value from this data, right? So this is the concept of a data product. And how does a data product look like? So what I'll do is I'll quickly jump through to say a data product is not like a mythical animal. It actually exists, and you can build a data product right now. Can you help me to? Can you help me switch screens? Thanks. So I have a Kubernetes instance running, and let me see if I can show you how does a data product look like. Let me get you this one. So I have a bunch of data products on this system. Let me say get data products -a. So this, for example, this is a small system on which you have a bunch of data products across multiple domains, and this is natively built within Kubernetes as an example, right? So this is a Kubernetes custom resource that we have defined, and these are examples over here. So if you want to dig deeper and understand better in terms of what is, I'll further. This is an example of a data product which does customer segmentation, and you can see that this data product belongs to the customer domain. There is a description against it. You can figure out what are all its input ports. You can figure out what are its output ports. And this is an example of a data product, right? You also have backstage and tap, which enables you to discover much more information about a data product, but this is a small example. We'll go back to the slides. Thanks. And this data product requires a platform in order for it to be provisioned. It requires CI/CD pipelines in order to build it. It requires infrastructure provisioning as an example based on the infrastructure that it requires. And this data product also needs other factors such as the ability to make it secure, to scan it, etc. And that's what a platform provides. And that's where we're looking at why do you need a data mesh platform? Now that you have a concept of data products and you know and understand what a data product is, your platforms is what enables you to build data products. Now, in a data mesh architecture, what does a data mesh platform look like? For me, in a data mesh platform, primarily 3 layers. The first one is the infrastructure utility plane. And this infrastructure utility plane enables you to provision the necessary infrastructure. And this could be in a multi-cloud system. It could be something that enables you to provision a SQL data store locally on your on-premises system. It enables you to provision an Amazon RDS instance in AWS, or it could enable you to provision Amazon SageMaker as an example on AWS. And this is where it enables teams to independently provision the sort of infrastructure that they need, rather than have to wait for a centralized team to turn on infrastructure that they need, right? And this particular plane, it's primarily managed by a platform operator who defines what's available within this particular utility plane. The second one is a data product experience plane, which is an open ecosystem which is used to create data products and manage the overall life cycle of data products. And this is where your data product developer, this is again another role within a domain team, like how you would have multiple other roles. You would have a data product developer within a domain team. This is a plane that he would use to create and manage the overall life cycle of a data product. The last one is a data mesh experience plane, where you would discover data products and you would sort of interact with the data products that have been created as part of this platform. And this is where your data product consumer can come in and explore what sort of data products exist. What about the quality of these data products? What about the liveliness of data within these data products? What about the freshness of data within these data products as an example, right? So this is a conceptual example of what a data product, of what a data mesh platform looks like, right? So how would you use a data mesh platform? Now, if you are a data product developer, you would jump onto the data product experience plane, and you would say, hey, I need to create a data product. These are its inputs, these are its outputs, and this is what is the processing layer of this particular data product. You would register it. And once you register that particular data product, the platform will bootstrap a repository, create a necessary pipeline to build that particular data product. It would provision the necessary infrastructure based on the metadata that you have embedded within your data product definition. It would then be up to the data product developer to develop the data product. The platform would then build the data product, secure it. It would deploy the data product across various environments because the platform is now managing all your environments. Then the developer is responsible for monitoring the data product, evolving it, as in continuously improving the data product, and maybe, if necessary, at a future point in time, retiring the data product, right? What about a data product consumer? So the data product consumer would then jump onto the data mesh experience plane, wherein they discover all the deployed data products. They could explore the various data products available, figure out all the various factors of the data product, could be quality, freshness, and other factors as we talked about, and they could consume that particular data product. Again, this is a conceptual example of what's a data product, what does a data platform consist of, and how we would use that particular data platform. And again, I would always like you to sort of remember that we have broken down what was a data warehouse or a data lakehouse and sort of moved it upfront further and democratized it across multiple domain teams. And we're also enabling them and empowering them to build these things by not having to depend on one single centralized team, right? And this is completely possible. But what does this mean from an AI and ML perspective? As you said, a lot of organizations would want to move to the left of that graph, wherein they want to enable themselves to build really innovative AI and ML models and use all those technologies that exist out there that we've been talking about for the past day and a half. If you're a data scientist who is using a data mesh platform as an example, you would initially do exploratory data analysis. You would want to know and understand what sort of data is available for you to solve a particular problem. Let's assume you're in an e-commerce domain. Again, I'll use the same example. You want to reduce the number of abandoned carts. If you're a data scientist, you want to explore what sort of data is available for me to understand the problem set. You would do exploratory data analysis. You would identify features of data that you need to create some sort of a model to understand why carts are abandoned. And that's where your feature stores comes in, when you identify the necessary features. Then you would create an hypothesis to say, why are carts being abandoned? And how can we enable customers to identify the right products and sort of reduce the number of carts that get abandoned? So you would do a hypothesis-based development, and that's when you use a data product experience plane. Once you have fine-tuned your hypothesis to say, now I know what I need to do, and based on my hypothesis, I'm generating a model, and that's where you use your data product experience plane to create this model, to validate your model, run tests against it, build it, and deploy it across multiple environments. And then you would use it to infer why carts are being abandoned, and you can run it at scale. These models can then be scaled independently, and these could be consumed by different teams based on what's available in your data mesh experience plane. And if your model requires any specific infrastructure, again, could be whatever you need. Could be a SQL store, could be an object store. This could also be provisioned through the infrastructure utility plane, right? So this is what a data mesh allows in terms of ensuring that you can build really innovative AI ML models, because right now you've democratized access to all these things into your teams rather than having them pinned on into one single team at the back end of your data warehouse. If you're a data scientist, again, working through this, you would identify your training data through the data mesh experience plane. You would identify the necessary features. Then you would build your ML model code, which you would again work through in terms of the data product experience plane. And then you would provision infrastructure. For example, in this case, if this requires something like Kubeflow, you would provision it through your infrastructure utility plane. Now that could be cross-plane, Terraform, or however you want to implement your platform, right? And for me, what we have done right now is we've not only enabled our domain teams to build data products, which are much more of aggregation, summarization, SQL access sort of data products, but we also enabled our domain teams to start to work through data science and build ML models and AI models based on this data platform, primarily through democratization of data access, decentralization, enabling them to provision the necessary infrastructure that they need and provision it on the fly. And this what enables teams to sort of solve problems in a very, using AI and ML and using applied intelligence through the data that they have collected within these particular domains. And that's what the platform enables through this, right? And what we have done through this conversation, I'm precisely on time, is the fact that we have moved organizations from being focused on data defense, which is again primarily focused on data quality and other metrics, to sort of say, how do you enable your teams to build and achieve value from the data that they have within their source domains? How do you unlock the value of data that you have? So for me, I feel a data mesh is an ideal example of an architecture that enables your organization to use technologies that we've been discussing about in the past day and a half. And that is me. Thanks a lot. It's on dot. Happy